Assalamu alaikum. This is the sixth lecture of Discrete Homotopy Theory. So I will explain in this lecture the definition of concatenation for infinite length path. Okay. So let's say X be a graph. The Here is any vertices X, X prime, and X double prime belongs to the vertices set of graph X. So given two paths, we have two paths gamma from x to x prime and sigma from x prime to x double prime in x. Okay, both path in lie in x. So both of length infinity, as we discussed in start. Their concatenation, if we concatenate both paths sigma and gamma from x to x double prime defined by this map sigma steric gamma steric sigma from I infinity to x is given by this equation. If we go from less than or equal to m plus, so we will lie in this gamma of I. If we greater than or equal to substitute in the place of I equal greater than or equal to m plus 1 m plus, so we will lie in here this. Okay, so okay, where m is the okay, we can see here m, where m plus is the smallest integer such that gamma of I is equal to x prime if we I substitute greater than or equal to m plus. Okay, and n minus is the largest integer such that if we substitute in the place of I is less than or equal to n, so we will get x prime. Okay, so by definition of, first of all, what is the definition of gamma and sigma? What Where gamma is the path from x to x prime, okay, in finite length such that there exists, according to the definition I discussed in previous videos, there exist m plus, m minus, and m plus. Both are integers such that if we substitute i's, we will get x for all I is less than equal to m minus. And if we substitute I is equal to I is, we will get x prime if for all I is greater than or equal to m plus. Okay. So by definition of gamma, or mention here in this definition, m plus is the smallest integer. M plus is the smallest integer. M plus is the smallest integer. We will get x prime if for all I is greater than or equal to m plus by definition of this gamma definition. And what is the definition of sigma? Sigma from x prime to x double prime. Okay, and there exist two integers, n minus and n plus belongs to integers such that if we substitute gamma sigma of I is equal to, we will get x prime, and for all I is greater than or equal for all I less than equal to n minus, and sigma of I is equal to x double prime if we substitute for all I greater than or equal to n minus n plus, sorry. So we can see here, sigma of I, we will get x prime if for all I is less than or equal to n minus, where n minus is the largest integer. Okay, largest integer, we can substitute all the points before n minus, we will get x prime. Okay, so how this is these two paths are concatenate in this lecture. So we substitute an equation. Where is the equation? This is the equation. If we substitute, okay, if we substitute here, if we substitute, let's say if we substitute gamma of I, gamma steric sigma of I, so we will lie in here if for all I is less than equal to m minus by the definition of this. So we will lie in gamma or gamma I, we will get x. This is the starting point of both two paths if for all I is less than equal to m minus. Okay, if we substitute gamma steric sigma, substitute I, where I is less than or equal to m plus. Okay, m plus is the By the definition, m plus is the smallest integer. Okay, remember m plus is the smallest integer. If we substitute for all I is greater than or equal to m plus, we will get x prime. After this, okay, at m or m plus 1, m plus 2, and so on, we will get x prime due to gamma path. Okay, so here, if we substitute m plus, so gamma of I is equal to x prime for all I is less than equal to m plus. Okay, if we substitute again m plus, okay, if m plus, so by definition we are lying here. So if we substitute here, so sigma of, in the place of I, we will substitute m plus. So because m plus is greater than or equal to, okay, equality is here. So we can substitute m plus. So m plus substitute in the place of I. So what we will get, m plus minus m plus plus n minus. So m plus is positive or negative cancel. Then we will get sigma of n minus, sorry, this is n minus. So according to the definition of sigma, sorry, according to the definition of sigma less than or equal to n, we will get x prime. Okay, so x prime, so we will get x prime. Then we will then we substitute m plus n, m plus 1. Suppose we substitute in the place of I is next to the m plus 1, m plus, okay, so we will lie here. So let's say m plus 1 minus m plus plus n minus, so they are cancel both m. So where m n minus plus 1, so next to the x prime, next to the next point to x prime. Then if we substitute if we substitute in the place of this, means if we substitute, this is the equation, I equal to gamma of I if I is less than equal to m plus sigma of I minus m plus plus n minus. Okay, if I is greater than equal to m plus. If we substitute in the place of I is what we will substitute. If we substitute this m plus n plus minus n minus, if we substitute this in the place of the I, so what we will get, so we can see m plus plus n plus minus n minus minus m plus plus n plus, oh sorry, n minus. Okay, so we can see there is a cancel values, n minus, the positive and negative cancel, that is cancelled. So we get n plus, sorry, n plus. So by definition of sigma, we will get x prime. So we can see where if we substitute m plus, so gamma, we will get x prime. And if we substitute m plus in this place, so again we will get again we will get x prime. So there is a concatenation between these two paths, there is infinite length. So by the definition, by this equation, by this reparametrization, we can see this is the concatenation between, because this is x prime is the final point, terminal point of gamma, and x prime is the initial point of sigma according to the definition of concatenation. So we can concatenate both the infinite length of paths. Okay, Allah Hafiz.